Hello, everyone. So here, what I'm going to be talking about is mostly about transmembrane proteins. It's something that you guys have not apparently understood, and you have some questions about. So when we have the cell membrane has two types of proteins. It has these peripheral membrane proteins, and then you have integral proteins, which we also like to call transmembrane proteins. Peripheral membrane proteins are proteins that are attached to the membrane, but on one side or the other. So meaning that it's attached to the one facing the cytosol or the one facing the outside, but it doesn't go through the cell membrane. Those are integral proteins. These are proteins that go through the whole cell membrane, and we call them transmembrane proteins. So transmembrane meaning going through the membrane proteins. And I'm going to give you here an example of transmembrane proteins. So you have ion channels as an example. So channel proteins. So channel proteins are literally proteins that have an opening. So hence a channel. So literally a protein that goes through the whole cell membrane and has a channel. So the outside, so basically this part of the protein is very hydrophilic because they like water. That's why they're facing out. And also the one that's in the cytosol, very hydrophilic. But the ones inside, so basically this here, are very hydrophobic because they're basically loving, they can stay in the kind of fatty acid or the lipid in the basically fatty acid chains. That's why they can stay. So the outside here is basically very phobic, but the inside, this whole channel is very hydrophilic. It's very hydrated actually, has a lot of water. And that's why it actually helps hydrophilic molecules to go through it, through these channels. So channels are literally, transmembrane proteins that have an opening and allows to basically things to go through it. And an example can be ion channels. So basically, these are channels that allow ions to go through because they basically have an opening and they let it go through. So that's an example of an ion channel. Then you have carrier proteins. So again, these are proteins that are literally, transmembrane proteins. So, are spamming or, going through the whole cell membrane. But these are different to channels. Channels, as we said, have an opening, complete opening here. While carriers, they do not have an opening. So as their name says, carrier, they carry proteins. So basically, they will bind to the proteins outside and they will transport them inside. So here, basically, this protein has to bind to the substrate. Once it's bound and transport it, basically, for example, to wherever it needs to go. So here, in this case, the cytoplasm. So that's the difference between channels and carrier proteins. So ion channels have this opening that let these molecules go through, while carrier are the ones that basically bind. That's the difference. And it's very important because, for example, here, how fast things travel. For example, how many molecules can go here per second depends on how much molecules there is because this is open. It's a big channel and it's going to allow as many as you want to go through. So it depends on how many there is. So if there's 20 here molecules and they'll basically go 5 per second, but yeah, 50, they might go actually 25 per second. So much, much more faster. So it all depends on basically how many. It's an open channel. So an open basically kind of it's hollow, it's open, and lets go things go through. Carrier, no, carrier has to bind it. So the how fast things are being transported depends on the carrier protein, and this is because, of course, they need to bind to it. It's not that it's open and as many things can go through goes. No, no, no. This protein has to bind to it, transport it, and then uh, basically let it go and then bind and basically transport it. So that's the difference between the carrier proteins and the ion channels.